Good afternoon, everyone. Welcome back. I'm Steve.
And I am Scott.
And together we're Backyard Musings, the one and only, the true science and technology channel.
And we are talking about the dark side of the moon, or the far side of the moon.
Right.
Oh.
This is very interesting. I mean, because now we have moon missions to the moon going on from different countries. Now, maybe this is staged on a film set, and all made up. Right?
In a warehouse in Inglewood?
In a warehouse in China. I mean, if there's conspiracy theorists for America going to the moon, there's got to be conspiracy theories for China going to the moon, right?
No, they got a lot more warehouses than we do. So,
scientists have discovered that the far side of the moon is colder deep within its interior than the side that always faces Earth. So the moon is tidal locked. We know what that means. It one side always faces the Earth, right? Because of the Earth's gravity. By analyzing rock and soil samples collected by China's Chang'e 6 mission, researchers found that the far side's lava formed at temperatures about 100 degrees Celsius lower than similar samples from the near side. This temperature difference hints that the moon's two faces go far deeper than the surface, possibly caused by uneven heat-producing elements or an ancient impact that shifted them toward the near side. Would you like to know more?
The hidden interior of the moon's far side may be significantly cooler than the side that always faces Earth. According to a new study co-led by researchers from University College London and Peking University, published in Nature Geoscience on September 30th, 2025, the research examined lunar rock and soil fragments collected last year by China's Chang'e 6 mission from a massive crater on the far side of the moon.
Okay, wait a second. Peking University? I thought it was Beijing. Peking was done away in the 50s when the communists took over.
Oh, well. Maybe it's a big warehouse, man. Maybe they got that thing in the warehouse.
You think they're in exile? Peking University is in exile somewhere?
I don't know. Could be. Yeah.
I'm so stupid.
Maybe they all moved to London.
Maybe.
Calling it Peking University.
Right next to that university. The scientists confirmed that the sample is around 2.8 billion years old and analyzed its mineral composition to determine how it formed. Their results suggest that the rock originated from lava deep inside the moon at roughly 1100 degrees Celsius, about 100 degrees cooler than samples taken from the near side.
I wonder if Peking University's mascot is the duck.
Peking duck?
All right, here we go. I'm co-author Professor Yang Li, based at UCL's Department of Earth Sciences and Peking University, said, quote, "The near side and far side of the moon are very different at the surface and potentially in the interior. It is one of the great mysteries of the moon. We call it the two-faced moon. A dramatic difference in temperature between the near and far side of the mantle has long been hypothesized, but our study provides the first evidence using real samples."
Co-author Mr. Zhulin Zhu, a PhD student at Peking University, said, quote, "These findings take us a step closer to understanding the two faces of the moon. They show us that the differences between the near and far side are not only at the surface, but go deep into the interior." I don't know how he figured out they go deep into the interior. It's not like they got a drill rig up there or a big crevice,
Yeah.
Or they got an ocean that they went down to the bottom of.
Purely speculation.
The far side has a thicker crust, is more mountainous and cratered, and appears to have been less volcanic, with fewer dark patches of basalt formed from ancient lava.
In their paper, the researchers noted that the far side of the interior may have been cooler due to having fewer heat-producing elements such as uranium, thorium, and potassium, which release heat due to radioactivity or radioactive decay. Okay.
Previous studies have suggested that this uneven distribution of heat-producing elements might have occurred after a massive asteroid or planetary body smashed into the far side, shaking up the moon's interior and pushing denser materials containing more heat-producing elements across to the near side.
Other theories are that the moon might have collided with a second, smaller moon early in its history, with near side and far side samples originating from two thermally different moonlets, or that the near side might be hotter due to the tug of Earth's gravity. Okay.
For the new study, the research team analyzed 300 grams of lunar soil allocated to the Beijing Research Institute of Uranium Geology. Chang'e, first author from the institute, explained, quote, the sample collected by the Chang'e 6 mission is the first ever from the far side of the moon. That's impressive. The team mapped selected parts of the sample, made up largely of grains of basalt, with an electron probe to determine its composition.
The researchers measured tiny variations in lead isotopes using an ion probe to date the rock as 2.8 billion years old. Man, I don't know. A technique relying on the fact that uranium decays into lead at a steady rate. The data were processed using a method refined by Professor Peter Vermisch of UCL Earth Sciences.
They then used several techniques to estimate the temperature of the sample while at different stages of its path when it was deep in the moon's interior. The first step was to analyze the composition of minerals and compare it to computer simulations to estimate the temperature of the rock when it formed or crystallized. This was compared to similar estimates for near-side rocks with a difference of 100 degrees Celsius.
The second approach was to go back further in the sample's history, inferring from its chemical makeup how hot its parent rock would have been. Example, before the parent rock melted into magma and later solidified again into the rock collected back by Chang'e 6. Comparing this to estimates for near-side samples collected by the Apollo missions, they again found about 100 degree Celsius difference. Okay.
As return samples are limited, right? I mean, you gotta burst off the moon, and with all that new weight on it, I guess that would offset from the fuel you use to get down. So it's limited. They worked with a team from Shandong University to estimate parent rock temperatures using satellite data of the Chang'e landing site on the far side. Comparing this with equivalent satellite data from the near side, again, finding a difference, this time of 70 degrees Celsius.
On the moon, heat-producing elements such as uranium, thorium, and potassium tend to occur together alongside phosphorus and rare earth elements in material known as creep-rich. That's the acronym derives from potassium having the chemical symbol K, rare earth elements REE, and P for phosphorus. Okay.
Leading theory of the moon's origin is that it formed out of debris created from a massive collision between Earth and a Mars-sized protoplanet. And that protoplanet we talked about, Theia, is that what it's called, Theia?
Yeah, I can't remember, but we did talk about something like that.
And so there was an accretion disk, and then that slowly formed into the moon and began wholly or mostly made of molten rock, lava, or magma. This magma solidified as it cooled, but creep elements were incompatible with the crystals that formed and thus stayed far longer in the magma. Scientists would expect the creep material to be evenly spread across the moon. Instead, it is thought to be bunched up in the near side mantle. The distribution of these elements may be why the near side has been more volcanically active.
Although the present temperature of the far and near sides of the moon's mantle is not known from the study, any imbalance in temperature between the two sides will likely persist for a very long time, with the moon cooling down very slowly from the moment it formed from a catastrophic impact. However, the research team are currently working on getting a definitive answer to this question.
Yeah.
We need boots on the ground up there.
If we're going to get boots on the ground, we got to build a habitat so we can live and farm and work, and then revolt and have their own country up there.
Yeah, because I mean, it shouldn't be any different there than in the space station, right? All they need to do is just take a International Space Station and figure out a way to
Land a
plan
bunch
it.
of pods and
Plan
link
it.
them.
Yeah.
Yeah. And then so they'll call it the Moon Congressional Republic, MCR.
Okay. You heard it here,
Or
folks.
Lunar Congressional Republic. There you go. LCR.
Okay. Okay. You
All
heard
right,
it here
folks.
again, folks. 2 times in one night.
Again. Thanks a lot. We'll see you.
See you tomorrow. Take care. Thank you.